All right, next up in calc, we've got integrations of bases other than e. There's a derivation for this that I could show you. I'm not sure it will actually help you remember it. So we're just going to get to the meat of the topic here. This is the formula that we are using to solve these problems or using it as a basis to solve the problems. The integration of a to the u power with the derivative of u is equal to 1 over the natural log of a times a to the u power plus c. Now, what this means is this. A is some number, numerical value, whatever. U is an algebraic expression, like a polynomial or just a variable, whatever. And so it's like using the chain rule, if you will. So let's look at some easy examples of this. Start with number 1 here. We have the integration of 2 to the x power dx, and the number here that we're involved, the base of these things is 2, and x is our u. So u is equal to x, which means du equals dx, which I probably should have put up, but I think you can figure that out. Now, using this formula here, where we have a, which here is 2. This is going to give us 1 over natural log of 2 right here, times a to the u power, so it's 2 to the x power plus c. Or, if you want to make one fraction, which is what I prefer, and of course I need to change that little bit right there. That should be 2 to the x power, not 2x. So let's fix that real quick. And there you have it, plus c. Okay? So, again, another scenario involving 3 this time. Exactly the same idea. A is 3, u is x, so, and then du is dx. So, following that same formula, 3 to the x power over the natural log of 3 plus c would be your answer. No big deal. So let's throw in a nice little complication here. Let's take the integration of x times 5 to the negative x squared dx. Now, we got to figure out a way to get rid of this x here. This is no issue right here. 5 is our a, obviously. Now our u, instead of being x, is negative x squared. But the nice thing about that is that when we take the derivative of that, that gives us negative 2x dx. Well, if I then replace, if I want to get rid of the x dx, I simply divide by that negative 2 over here, and I get x dx, which is this quantity right here, is equal to du over negative 2. So I'm going to try and fit this format right here, integration of a to the u power times the derivative of u, by taking the x dx and replacing that with negative du over 2. A is 5, and u is negative x squared. And so that's going to transform this into this. So a to the u power du. Well, I have to get rid of that negative 2 though, so I'm going to bring out the negative 1/2. That's a constant. We don't have to worry about that. If you get it out quickly, you don't have to be dealing with all these difficult complications on your paper, trying to erase and get it right. And just get it out of the way, and life is grand. So now we have 5 to u du. Well, that fits the formula perfectly from what we have there. So we have negative 1/2 times 5 to the u power over natural log of 5. So that negative 1/2, because a negative here with a 2 denominator here, and here's your answer for that. Now we can replace the u with negative x squared, which we have, and we have 2 natural log of 5. Now 2 natural log of 5 is now a multiplication of 2 exponents for all practical purposes. We can make that natural log of 25, or more importantly, we have a negative x squared, which means, and I don't like answers with negative exponents in it, so please change that over to a positive exponent by flipping that to the denominator. And you get 2 natural log of 5 times 5 to the x squared power. This is clean. You can do some of that if you want to make that natural log of 25, that's fine, don't have to, but if you want to show off, go for it. The next one is 2 to the x power dx. Now we have a is 2, and u is x, and therefore du is equal to dx. What's different about this is now we have a definite integration. We're going from -1 to 2, so we can come up with a numerical value for this answer. It's not indefinite, it's now we have a definite integration. So we do the same thing we did before. This is going to be 2 to the u over natural log of 2, but now we're going from -1 to 2 for this. We don't have to worry about the plus c because when they subtract out, the c's negate each other, they're gone. So, we also know that the natural log of 2 is a constant. What value is it? I don't really care. I mean, if you want to punch it out and give me an answer for that, I'll probably have to spend a little more time grading your paper, but that's fine. We're just going to leave it as natural log of 2 and just pull it out of there. Okay, and that's going to leave this to be integrated right here from -1 to, not integrated, but we're going to use this for our calculations for subtracting. It's going from -1 to 2, so I'm going to replace the x with 2 and -1 and subtract those two values. That gives me 1 over the natural log of 2 times 4 minus 1/2, which is 3.5, or I prefer 7/2. Don't give me a mixed number, that's kind of messy. Times 1 over the natural log of 2. So we got 7 over 2 natural log of 2. If you want to leave it like that, again, that's fine. However, you are multiplying exponents here. So this becomes natural log of 2 squared, because that's 2 to the second power. Power over power, you're multiplying. And that gives you 4. It's not 2 times 2, it's 2 to the second power. Although technically the same thing, we're describing two different mathematical operations there. Either answer is correct. I will take either one. Your college professor may change his or her mind about that when you take that wonderful freshman calc class, but we'll see. Or you'll see, I won't see, I don't care. Number 5, the last one we're going to do here, we have this kind of format here. We now have 2 substitutions we're making, or 2 of those processes. One from the natural log of 5, or just the base 5, one for the base 3. And using the same process, we're going to get 5 to the x power over natural log of 5, minus 3 to the x power over natural log of 3. We could have used the a and the u thing, but at this point I think you're probably pretty familiar with the simplicity of each part of this. So now this is going to go from 0 to 1, so we take the 1, replace the x's with 1 here. So we get 5 over natural log of 5 plus 1 over natural log of 5. Now replace, replace the 1 here, gives a 5, and 5 to the 0 power is 1. And that's what you do with 5s and 3s, do the same thing. 3 to the first power of the natural log of 3, which is 3 over the natural log of 3. 3 to the 0 power is 1, so 1 over the natural log of 3. Subtract the quantities within them. 4 over natural log of 5 minus 2 over the natural log of 3. That's all there is to this. Again, calculus is just a bunch of mathematical manipulations to try to come up with a way to simplify things out. The simpler the better. But we're basing everything on that one formula, so keep that in mind as you go through it. Yes, it will be provided on the test anyway, but get used to using it. Okay? Your practice problems will be shown when you get the script. Have fun.